Yeah, good morning to one and all. So here we would like to discuss about the concept regarding to the gated D latch. In last class we discussed about gated SR latch. So gated SR latch is nothing but it is having one gate, one NAND SR latch, and along with this we have one steering gate. Now in this particular gated SR latch we can conclude that by instead of having two inputs as a set and reset, simply we can have one input called that is data input. So that data input can be treated as data latch. So we can say this as a data latch also. So in this particular concept we can say that, so here by observing particular truth table of this particular gated SR latch, we can say that these are the two conditions we can observe here. So these are the two conditions we can observe. So I am pointing out here, just check it out. Yeah, by observing this particular two states. Now in this particular first case, s is equal to 0 and r is equal to 1. This is my one case, and in this particular case s is equal to 1 and r is equal to 0. So by these two we can say that my s and r values are jumping with each other, which means that s is for some time it is 0, for some time it is 1, like s is 1 and 0, like with these two are complement with each other. Therefore instead of these two, simply we can have one input name. So instead of having two input names s and r, simply we can have one input name as data, that is nothing but d. So we can modify this sr simply by connecting one line with respect to s and r. So simply you can keep one s and r line here with this particular statement we can say. So if we combine these two s and r, we combine these two s and r, simply along with this one input d, along with this input d, and we can have one more inverter. Why? Because s is for a one time it is 0 and next time it is a 1, like that we can say from this particular table. So for that particular reason, so this is what we can consider here. So that is what I explained here, gated D latch. So instead of having both the inputs S and R, simply I have only D as my input. So this we can consider S, and this we can consider R. So here I kept one inverter here, just only having one input that is named D, that is data. So D as my input. This is our already we seen this particular concept in the last concept. Okay, so so this is our gated SR latch. So just you kept one NAND gate, one inverter in front of this particular gated SR latch. Now we can treat the truth table. How you are getting this truth table, I will explain here. Now, so let us have my D value. Initially, I would like to consider my D value, which is equals to 0. So when D value is equal to 0, so this 0 is coming in this direction and which is moving here, and the value will come here as 1 here, and the 0 is coming directly as it is here. Now when s is equal to 0 and r is equal to 1, you can observe from the truth table, when s is equal to 0 r is equal to 1, when s is equal to 0 r is equal to 1, what is the state here? Reset state you are getting output, that is the output I am representing here as reset state. And in the second condition, if I would like to consider my another input as d is equal to 1, if my d is equals to 1, if I would like to consider d is equal to 1, so my input at s is equal to 1 and at r is equals to 0, I am representing with yellow. Okay, therefore when 1 and 0 condition, so here I can observe that when 1 and 0 condition, 1 0 condition, my output obviously I am getting as set state. So that is what I am getting, set state. So this is d is equal to 0, you are getting your reset state as your output. And when d is equal to 1 and your state of output is set state. So as we defined earlier, when my enable is equals to 0, there is no change in your circuit. That is what we get by defaultly. So if your enable is equals to 0 by defaultly, when this particular NAND gate input is equals to 0 means the output is always equals to 1 and the output is always equals to 1. So when both the inputs are 1 means no change state is occurring. So that is what here we can observe when no change state is occurring. So this is what the concept regarding to the gated delatch. So here we are using enable. Enable is always equals to 1. When enable is equals to 1 only, you are getting set and reset state is occurring. So this is what the concept regarding to the gated delatch. So in the next class we would like to discuss about flip-flop concept. So thank you.